Hey folks, as promised, I'm going to solve this question number 6 from the multiple choice questions sheet from today, Friday, January 29th. Okay, that's when we got cut off with. So we're given the heat of formation for water of negative 286 kilojoules per mole. Ultimately, we have to find the heat of formation for magnesium oxide, and we're given these two reactions and their delta H values. Okay, so because these are not formation reactions, they're just regular chemical equations and delta H's, this portion is a Hess's law portion. Okay, so basically we want to add these two reactions together appropriately to cancel some stuff out and adjust our delta H accordingly. So what I would do here, because in the first reaction I have two hydrochloric acid solutions on the left and a magnesium chloride solution on the right. In the second equation, I have that as well. I'm just going to flip-flop this second reaction so that the magnesium chloride and hydrochloric acid switch positions, and I can then cancel them out. So I'm just going to rewrite this equation and its flipped delta H right underneath here. So I have Mg, magnesium chloride solution, plus water produces magnesium oxide and hydrochloric acid. Now what I do is I need to flip the sign of the delta H. Okay, the next thing I can do here is I can merge that first equation and that revamped second equation together. And I can cancel things out that appear on opposite sides. Okay, so, and then I'll add my delta H's. So underneath here, so I have more space, I'm just gonna write them together. So I have the magnesium solid from the first equation plus the water from that second equation produces magnesium oxide and hydrogen gas. Okay, and I'm going to add the delta H values together. So I'll add negative 467 plus 151. And that gives me negative 316 kilojoules per mole for this reaction. Now, in the prompt, it tells us the heat of formation for water, and it's asking for the heat of formation for magnesium oxide. So now I can use the heat of formation for water, I can use the delta H for the overall reaction, and I can solve for the heat of formation for magnesium oxide using my summation formula from my reference sheet. So that summation formula, remember, delta H is equal to the sum of the heats of formation of products minus the sum of the heats of formation of the reactants. Okay, so I have the delta H because I merged my equations together and merged their delta H's. Whoa. So I have the delta H, and I'll put that over here. So that's negative 316. Now for the products are magnesium oxide and hydrogen. We're trying to find the heat of formation of magnesium oxide, and we know because hydrogen is an element, its heat of formation is 0. So my products the heat of formation of my products is just composed of the magnesium oxide. And since its stoichiometric coefficient is just 1, it's just X here. Okay, so that's what I'm trying to find. We know that hydrogen is 0. We would also know then that the magnesium on the reactant side is 0. And we're given the heat of formation of water, which is negative 286. So there's my negative 286 that I will just put down here. Okay, so that's all of my reactants that I need to account for. There's all the products I need to account for. So now I just have this negative 316, I'm just cleaning it up, equals X minus negative 286. So again, I'm just doing this step by step to be super careful with my signs and my operations. So X is equal to negative 313 minus 286, which is negative 599 kilojoules per mole. Okay, that is a tough question. Obviously, that's not something you would have to do by hand for a multiple choice on an AP exam. But, and even in a free response question, it would probably guide you in a multi-step fashion, a multi-part question to first, combine these, and then it would lead you into finding the heat of formation for magnesium oxides. So that's definitely a tough critical thinking question that does not provide you with a lot of support, but I hope that that thought process and the setup kind of flows for you. Bye.